we're here to talk about building an e-commerce backend with NoSQL, and we're actually going to show you how to do it on Apache Cassandra, as well as the AstraDB or Cassandra as a service that that we offer through DataStax. And we're also going to have a streaming component to it as well, in terms of like moving like web orders around later on that leans heavily on Pulsar. So that's going to be really cool too. Yep. So anyway, yes, we are in room D. If you're looking, like we just said, looking for someone else, you're probably going to want like room E or F. Or
That's right. Yeah, exactly.
Oh, and by the way, hat tip to the Azul guys. These hats are super cool. I always said if I had a hat that said JVM on it, I would wear that fucking thing everywhere. And here we go.
Yeah.
What's funny is that when you look in the mirror, it says MVC on it, which is funny because that's the pattern we're going to talk about today. So,
that's right.
So there we go.
Exactly. Works. Yeah.
All right.
Okay.
Well,
yeah. So okay. Sorry. Yeah. Since the microphone only works in here. So yeah. So I'm Mary Grygleski. I'm maybe some of you I recognize from the CJUG organization. Are you members? Right. Some of you are members of CJUG. Yeah. I hope you are. I know Dan. I know Logan. I know Che and couple Josh, and yeah, so welcome if you are from, especially if you're from CJUG or even anywhere you're from. So just really nice, and we have Marcus too, who actually you came and talked for us too. So yeah, thank you. But anyway, this is also like about, let me be quick too, since we have to squeeze down the original workshop from an 8-hour workshop to 1 hour, so we're trying to kind of rushing through a little bit. So pardon us. So okay, so I'm at DataStax now. I'm a passionate advocate. I'm also a Java champion, and also running the Chicago Java Users Group, and also speaking everywhere too, and all these other things. As you can see, this is how you can get a hold of me, but I think folks here in Chicago knows how to find me. So yeah, okay, that's me. So I won't say too much. We have Aaron.
No worries, no worries. I'm Aaron Ploetz. I'm also a developer advocate for DataStax. I'm one of the few speakers here who's not a Java champion, so I hope that's okay. But I have a lot of experience actually working more on the database side. I actually got my start with Cassandra. We had a fairly decent sized Cassandra cluster at Granger right here in town, where I used to work. Well, geez, a little more than 10 years ago now. I spent a lot of time at Target, coaching teams on database selection, and like database tuning, performance, and how to like build good queries. And I've worked as an author on a couple of books, both on distributed databases. One focuses heavily on Cassandra, but yeah, that's me. All right, so real quick, this is our agenda for today. We're just going to talk about architecture, use cases. When you're talking about choosing an appropriate data store, use case is probably the most important thing you can think of there. We're going to go into how to do like appropriate data modeling for Cassandra. Talk about our Spring Boot service layer, and then get into some streaming on the end, and then I'll show you how this all gets put together in a little demo at the end. Yeah. So, all right. So, when you're building a website that's you're hoping to make money with, there's a lot of components that go into it. You can have like loyalty programs, gift registry. You can do something fancy with promotions and how to reach your customers. But really, when it comes down to it, there's like add-on components, and then there's like the more core components. Things you absolutely have to have, and that's kind of what we're going to focus on. That was the focus of what was going to be our all-day workshop that we've condensed down into about half the number of slides that we had before. So I apologize if it comes off as maybe a little disjointed, but these are the 4 use cases that we're going to focus on for today. Oh, and my puzzle animation doesn't do so well with the black background. Okay. Anyway, so here's the tech stack that we're going to talk about today. So on the data store backend, we're going to be using AstraDB just because it's a quick way to stand up a Cassandra cluster to show you all how that works. We're going to have Astra streaming, which is essentially Pulsar as a service, cloud native. The service layer, again, as I mentioned, it's Spring Boot, Spring Data, and then for the UI, we just have a simple like React, Node.js, Tailwind CSS site sitting on top of it. that aspect really isn't the focus of our presentation today, but it's kind of essential. You know, you can make the greatest backend, but nobody's using links as a browser anymore. So you do want to put some thought into how it looks. All right, so hey, real quick, you've heard me mention a little bit about Astra. Really, like I mentioned, it's a Cassandra as a service that's out in the cloud. And actually, if you just want to check it out, you can sign up for a free tier, not have to put any payment info down if you just want to mess around with it and just see what it can do. So it's super easy to use, actually. And then likewise, we have Astra Streaming, which is, again, built off of Pulsar. And same thing, you can mess around with that on the free account, and that's totally cool. All right, so why would we go with Cassandra, actually, in terms of supporting things like e-commerce? Well, really, all database selection, and analyzing use cases, it really comes down to what's commonly known as Brewer's cap theorem. He wrote a paper back in 1999. Actually, it was co-authored by Dr. Armando Fox, who nobody remembers. But Dr. Eric Brewer wrote the Harvest Yield and Scalable Tolerant Systems paper. And essentially what he said in there is that all distributed systems would try to achieve these three principles, of consistency, availability, and withstanding network partitions. But realistically, they could only do two. So that's what it comes down to. It's a choice about making trade-offs, essentially. What do you want to be good at versus what can you afford to be okay at? So then you get your data store systems classified as like your CP, your CA, like the relational databases, and then AP. So when it comes down to it, you've got your relational databases, like I mentioned, in the CA world. Your document stores do tend to be CP. Now, this is just out of the box. Some of these can be configured kind of on the fly to lean one way or the other, or lean away from how they're engineered. Like you can certainly tune Cassandra to be more consistent, but it's I've always found that that's a good thing. When you have a product, to use it in the way it was intended and not try to make it do things it wasn't engineered to do. So that's just me. Anyway, so the point we're going to be talking about today is definitely on the AP side. So think highly available, able to withstand network and partition outages, but eventually consistent. All right. So why wouldn't we pick an RDBMS for this? An RDBMS is still a really great system. It has the benefit of 40 plus years of computer science behind it. But the main thing is that scalability, and I'm talking horizontal scalability, was just not a part of the original thought behind how those systems were built. There was an old Oracle DBA I used to work with at Target. Who won, and he was Russian, by the way, so he had a heavy accent. He was like, Aaron, you're working hard just to get 40,000 IOPS. I can get 400,000 IOPS, like no problem. And I'm like, yeah, Janusz, except you have to pay $11 million over to Oracle to do it. Anyway, I digress. So you can scale relational databases, but eventually you get to a point, where you're a heavy retailer, like you're looking at your Targets, your Walmarts, your Amazons, where things are coming at you all the time, and it becomes more difficult to have things like primary servers or leader elected servers, and when you lose something for a little bit, it's got to fail over to something else. So that can get kind of tricky, and also geographic distribution. You get to the point eventually, with these larger retailers where you have your mobile and your web customers like on the West Coast. Well, you want to make sure they're hitting a data store and a service layer that's also on the West Coast. And same on the East Coast. You don't want them jumping across over to California just for a data call. Well, the thing is that you still want those data sets to be synced. And that's where geographic distribution and using a data store that's designed with that in mind really comes into play. Why not a document store? My master's thesis was actually about building out an e-commerce system on top of like MongoDB. If I could go back 12 years, I might change some of my opinions on that. But you know, when it really comes down to it, that strong consistency can limit your throughput. Supporting Mongo in production for 5 years, I've seen when queries reach a point where they start pulling too much through, they start to become CPU bound, and then you'll notice your Mongo containers really starting to hit their max in terms of resources. You know, and the other thing is that, you know, schema is actually important. You know, NoSQL made a lot of noise when it first came on the scene, you know, what a good 15 years ago or so, about, oh, it's schemaless. Well, you know, you really do want to make sure that you've got schema. That can actually help you. You know, it makes sense maybe if you have a whole lot of different types of documents or types of records that maybe don't share all the same properties. But really, you know, what people found out over the years is that's usually not the case. So especially in e-commerce, you know, you really do find out that schema is important here. And then just for the DevOps folks in the room, when you're building out data stores on Kubernetes, things like Cassandra are really easy because every node can do everything. You know, there are some distributed data stores that have things like primary nodes and ingest nodes and indexing nodes and other things like that. And those individual roles can sometimes be problematic when you lose a pod in Kubernetes and you're getting something replaced. You want to make sure it's replacing for that like role. So that can get kind of tricky. All right, so again, Cassandra, meant to be distributed. It's built with read and write performance in mind. It's actually really, really good at write performance, just in the way that it handles things like durability and in-memory writes. We talked about high availability. It has a little bit of like self-healing and automation. You know, if you do happen to lose one particular node, you actually do get hints and things that store up. Like if you're still trying to write to that node that's down, its neighboring nodes actually kind of take care of those token ranges, and then can actually like stream back over once it comes back up. And if you're looking for geographic distribution, you know, no other data store, from what I've seen, really handles that better than Cassandra does. You can build up, you know, logical data centers that may or may not relate to the same physical data center. Sometimes there are times you may want to do that. And you know, I mean, I've built clusters that have been spread across 8 logical data centers before. Just given where the data needed to be or the type of processing that needed to happen. So it definitely can do a very good job of keeping those data sets in sync. Cassandra's platform agnostic. You know, it'll run on pretty much anything. When it first came out, it was really running on like a lot of bare metal servers. For a while there, it was running on, you know, you could make it run on VMs very well. I spent a lot of years running it on OpenStack, despite all of the industry-wide knowledge of, oh my God, don't ever run a database on OpenStack, but we were able to actually make that run pretty well. And now it runs in Kubernetes, and even with a small amount of resources. You know, we've kind of found that, you know, when you have a lot of small containers running Cassandra, it actually tends to run a little better than maybe like 3 gigantic, big, beefy database servers. So yeah, and vendor independent, you know, you can really run it in any cloud, pretty much on any operating system, although I would not run it on Windows, but it can be made to run on Windows. Just, yeah. All right. So, you know, and again, it takes us to Astra, Cassandra as a service, no operational overhead. The thing we hear the most is, hey, Cassandra is great. You know, Netflix uses it, Apple uses it at such large scale. But it's kind of a pain to run. It's kind of a pain to operate on. Well, AstraDB takes care of that. Deploys on multiple cloud vendors. You can actually spread logical data centers across different cloud vendors. And it has no-touch scalability. So if your cluster starts getting hammered, you know, you'll get new pods provisioned, and it'll kind of spread out like that. So, all right. So of course, we've talked about Cassandra and Astra. You've probably heard that Cassandra is difficult to work with. It does have that reputation. The main thing is that when you take care in building an appropriate data model for Cassandra, or for any distributed system for that matter, you start putting thought behind making sure that you can solve all of your queries by going to a single instance. So that way you're making the least amount of network trips as possible. And when you look at things like, a lot of folks will say, well, you can't really do a join. Well, that's the thing. You kind of have to design for that ahead of time. So in this particular case, if you had a table of employees and a table of departments, rather than selecting from employees and joining on departments, you would really just build a table, denormalized, so to speak, that had all of that information in one. And again, it's all about making sure that you can get everything you need for your query in one trip. Sometimes that may lead to things like data duplication, but really that's okay. If you look at how data storage has progressed over the years, namely in terms of price per gigabyte. I mean, in 1980, if you wanted a gigabyte of disk storage, I mean, you had to have IBM wheel in this giant 4 or 5 foot platter, on a cart, and it would cost you about $1 million. And now I can go to Newegg and I can get a 2 terabyte drive for $40. Well, maybe a little more. Yeah.
So doesn't that cost you? Does it need an overhead for making sure the data is consistent?
So you saw the next point of manual integrity enforcement. Sometimes it does lead to a little bit of that. Cassandra's getting better about that, though. Actually, next week I'm going to be at ApacheCon, and one of my coworkers, Patrick, is putting on a talk about ACID transactions in Cassandra, mainly around making sure that a lot of that manual integrity work becomes a thing of the past. So that's going to be really cool. If anyone's going to ApacheCon, I highly recommend that one. All right. So to manage the data layer, we have Spring Data Cassandra. It makes it super easy to access your data stores, put in your connection properties. It takes a lot of that boilerplate code. And I'm sure those of you folks who have used Spring Data know that there's just a whole lot of code involved in establishing your connection, making sure you've got your queries looking right and getting that all in there. Well, this kind of reduces it, and it actually works really well. It also has some methods that don't really work well with Cassandra. And as a side note here, I couldn't decide on which Return of the Jedi reference to go with, so I went with both. The thing is that you have to think about is, what does the query code look like underneath? When it does, really what Spring Data is doing is it's abstracting a lot of that data access code away from you. So you can say, oh, find my ID, and here's the ID, and it'll just do it if you have your repos set up properly and have everything wired together. And if you say find all, well, that's where it does things like select star from and just doesn't have a where clause. And that's where you're going to start doing things where, again, going back to our, hey, we want to pull everything back in one network trip. That's where it's going to go look at one node in Cassandra, and then that one node is going to have to talk to every other node in the cluster, and that's where things really start to get expensive. Count is the same. Doing a save all actually does a batch transaction in Cassandra behind the scenes, but batch in Cassandra doesn't work the same way as it does in the relational world. You'll run into problems if you're trying to save 4 or 5 items in a save all, that'll be okay. If you're trying to save 45,000 items in a save all, that's probably going to crash in timeout. And that's where my note with Mon Mothma here is many containers died to bring us this information. I've seen that happen too. All right, so a little bit about the architecture. Use cases, so again, we're gonna look at how we build our product catalog, and that's with product data, pricing. I actually took all of my Cassandra swag that I've assembled over the years and shot pictures of them on my wall, so that's why my Cassandra 3.0 contributor shirt looks a little wrinkly there, but that's okay. And has dog hair on it. We're gonna talk a little bit about putting a shopping cart together too. Actually, we have a Git repo that has all of this code. It's from our live workshop, so it includes on how to build the data definition language. Rows to insert as well, so you have product data. But yes, we'll go through a shopping cart, user profile. Again, your customers need to be able to log in. Sure, you could have them log in as guest, and that's okay too. But in this case, we're going to have a single sign-on with your Google account. And of course, there are ways that you can wire together things like log in with Facebook. You can even do login with GitHub, which is pretty cool, although probably not terribly useful in like a Walmart type of a scenario, but you could still do it if you wanted to. And then we're going to talk about the ordering system. And the ordering system, again, is about essentially taking what you have in your cart, processing it through, figuring out what you owe or what your customer owes, and making sure that you can accept the payment. As far as like processing that order, now remember too, we're talking about a larger enterprise here with a large site. So that order gets sent down to a warehouse, and then somebody has to go, or a robot, Amazon's case, has to go and like pick those items together. Somebody's got to go ahead, wrap them up, and ship them. So that order data needs to bounce around a few internal business units actually before you're done with it. And then, of course, for order history, order status, this way your customer can kind of see, hey, where's my order at? Oh, it's picked, so it's almost ready for shipping. So things like that. All right, so that brings us to starting to look at like how do we kind of conceive how the data model looks? How does everything go together? We can come up with relationships. Like a user has a shopping cart. Shopping cart contains products. Product has things like a name and a description. A shopping cart actually could have like a name, or it could be active or inactive. You could extend out shopping carts too to be like somewhat of like a wish list kind of a functionality too. So that's where you start thinking about, okay, so a user could have multiple carts, but that's really more of a there's a complete rabbit hole on that one that we could go down. All right. So, of course, that's going to lead us to the data model. Start thinking about how these entities all interact with each other. And that'll take us to, some of the actions here. And I think this is really important to, to kind of have a look at and think about what your actions are. What do your customers need to do, and what do they need to get? And that's really going to lead you to what your queries are. You'll think about things where like, oh, okay, so the customer has to add products to the cart. Customer has to check out. Customer has to enter their address. Or, they could be like a smaller business that orders from your site as well. In that case, they might have multiple addresses. They might have a mailing address. They might have a shipping address. They might have a billing address. And those could all be different. So that's something you have to keep in mind too when you start looking at how you're going to model a lot of that out. So for this example, I decided to look at and kind of show a little bit about how we put like some of the cart queries, some of the cart design together. I already mentioned some of these, like we need to query all carts for a user, need to be able to look at the user's active cart, see all the products in their cart, things like that. And that's actually going to drive us toward putting together how we're going to pull that data back from our data store. Before we get there, though, we start looking at what the table structures need to look like. Your items in your cart are going to have things like their brand, description, model, maybe an image or two. Images is good to think about because again, you might have a product that has multiple images, and that's good to be able to account for that as well. You'll be, and you'll probably want a product timestamp as well. That way you have some idea like about what order products were added to the cart. That's always good to keep an eye on. See, and that actually comes down to building the table. In Cassandra has their own like subset of SQL. It's known as CQL, Cassandra Query Language. It's very SQL-ish. But there are just some things that obviously it doesn't have based on limitations of of distributed systems. So this is solving the cart query. It's clustering on timestamp. That way when I pull back from my cart ID partition, I'm actually going to get my products listed in descending order of how they were added. So the most recent products added will be at the top first. And of course, we're even going to have a TTL on this one as well, which is a default time to live. And if I'm remembering here, 5,184,000 seconds is 60 days, maybe? So you might be asking, well, why would we have a time to live on a cart? And you know, I can tell you, when I was at Target, every now and then we'd get a bot attack on the site. And the thing is that the bots seemed to target long-lived carts. So, you know, at some point, somebody was going out there and adding a whole bunch of products to a cart. Now, of course, you can tell bot activity, you know, from human activity. You know, 2 products added in the span of a minute, that's probably a human. You know, 200 products added in a minute, that's probably not a human. So the thing to remember on this, and that 60-day TTL, you know, obviously that's something that you know, would better be, you know, it's going to depend on your business and you know, kind of the requirements there. You know, I think 60 days is a decent enough time. That's kind of like a good enough of, hey, I've been away from the site long enough. Any more than that, I probably don't care what I left in that cart. As well as, oh, hey, I was looking at this last week, so I want to come back this week, and maybe now I'll buy it. I think that's a reasonable time. But the idea is that having a time to live and getting rid of old carts, that decreases your surface of attack. We never really did figure out exactly what their driving goal was with a bot attack. I have a feeling it was to like kind of pull or scrape product prices out of all the products that they'd added into that cart, but that was my theory. You know, something else you could try too is that the product ad service layer is something that you know, you could put a rate limiter on. Would probably not be a bad idea either, just to make sure that they can't do a few hundred or even 1,000 ads in less than a minute. But something to think about. All right, so the service layer. This is just a little bit of the Swagger spec that got generated along with our service backend here. Basically, you know, it comes down to get some. You know, if you're logging in with Google, in this case, in that top one, that's going to you know, allow you to log in with you know, like a single sign-on provider. The next one is if you're retrieving user data by user ID. The one after that is if you're retrieving a user data by an email, which is definitely something that you may want to do as well. So just for the example, you know, it comes down to doing a simple select. You know, user by email. Hey, select from, you know, where user email equals, and then, you know, you have your email in there and you get your ID back. You know, simple enough. Oh yeah, I was. This is where I was going to bounce over. How big is that here? You know what? Yeah, let me boost that up a little bit. Okay, so this is where we kind of have our, this is our order rest controller. So here we've defined, you know, the call for pulling back by user ID. And it's short and sweet. And let's see here. Oh, well, my bad. This is actually placing an order. I got ahead of myself there. But yeah, so you know, it you know, pulls in the product list from the cart, and you know, generates up a actually pulls in the cart ID. You know, it actually this right here, it actually will pull in or generate a time UUID or a type 1 UUID. You know, most people when they think about, you know, the UUID is like a type 4 really. But Cassandra actually supports type 1 as a data type. So you can have something that's a unique identifier that's based on, you know, like what time it is. So that's something that I found to be really useful for this one too. Yep, putting together, you know, order subtotal, tax, shipping and handling. Now there's another part. Oh yeah, here we go. Called a repository to save, as well as, oh yeah, getting rid of the old cart. So now that we've converted to an order, we don't want the old cart hanging around. So make sure we pull that. And then this is where we go ahead and we put it on the Pulsar topic. Oh, and I had that commented out. Why did I do that? Anyway, well, I digress. We're not running the code for my laptop anyway, but you know, the idea is, oh, sorry, it's just above here. There we go. Send to order stream. Simple enough. And if I scroll down some, there we go. Oh, yeah, and that's just a simple, you know, send on a Pulsar producer. Easy, easy. And then, you know, we also have an order processor that runs. It's a separate process, but really all it does for the purposes of the demonstration is to take from, you know, it looks at like one topic in Pulsar and like takes it and moves it over to the next one, kind of simulating, you know, the actions of the business unit, like you know, hey, I found this in the pending orders topic. Well, I'm going to take this order and go pick its items and then bring it back so it's ready for shipping. So then it'll move from there, you know, on over to the picked topic and then over to shipped and completed, so on and so forth. Well, now we can talk a little bit about streaming.
Okay. Oh, thank you. Yeah, Aaron, thank you. Yeah.
Oh, yeah, of course.
Actually, wanted to ask folks if anybody is already using Cassandra. I guess we didn't ask, right? Yeah, maybe just get an idea.
Oh, hey, we got one.
In my last project in Wall Street,
Okay.
Oh, okay.
we were using DataStack Cassandra, we were not using Astra.
Oh,
Okay.
okay. Oh, cool.
Oh, DSC is still cool. That works.
Yeah, that's right. Yeah. Okay. So, and then now the question is, how many of you are using, maybe have heard of Pulsar, Apache Pulsar? Yeah. Okay.
Oh,
So
hey, we got a few.
a few. So that's good.
Good.
But that's okay. It's a relatively new streaming platform. It's more catered, I guess, for cloud native type of usage. And also, too, I have folks asking if it's a replacement for Kafka. I'd say, you know, Kafka was designed before Pulsar. So Pulsar came out because Yahoo found a need, right, to have something, event streaming platform in the cloud. So that's when they started doing Pulsar, and now becoming actually more important because a lot more systems now are going into the cloud. You need to worry about all of these concerns that are running in the cloud, and so that's when Pulsar comes in. And DataStax, too, about a year and a half ago, started adopting Pulsar. So yeah, that's how I got brought into to do efficacy on Pulsar. And as I'm learning more too, it's pretty exciting technology. So I know it's kind of new and it's kind of an introduction for you. So you can also start to consider that. I think it's very promising. So, okay, but back to this example, e-commerce. Yeah, we're doing the user's order, right? And so we can leverage on a streaming platform such as Pulsar. And again, right, it allows business functions on an order and track the status timeline of an order quite well. Like if you want to do streaming type of kind of capability, right? So now why use Astra Streaming and Pulsar? So just give you some idea. So again, Pulsar was designed with the cloud in mind, very much cloud native, and is also supporting like geo-replication. So it has this geographic awareness. Actually, kind of goes very well with Cassandra. So Cassandra also is about geo-awareness. So kind of in that direction, right? Okay, and then Pulsar itself is essentially it pops up, adopts that design pattern, but you can also use it as a queue too, from a more subscription perspective. Now, I won't have time to get into all of these details, and in fact, the stream native person, Tim Span, is actually doing another talk, I realized, scheduled at the same time doing Pulsar 101. And we also have many resources for you, but this is just to kind of get you excited and learn more about Pulsar that you can consider using it instead of using something like Kafka, for example, right, for your specific needs. So, okay, so it's a pops up. It has a serverless broker. It can support streaming, right, queuing, and all in one. So as you know, too, using this kind of architecture, it helps you to scale very easily. So for this example, we probably don't have to worry about scalability as much. But let's say if you're working with like Target and like right before holidays, right, you get tons of orders, things like that. So you can consider something like Pulsar, for example, to kind of drive your system. And the one good thing about Pulsar is that it separates out the compute and the storage. As you know, when you do heavy duty, like all of these asynchronous messaging broker, it handles so many messages, right? So you have to manage it. So Pulsar actually separates out and have Apache Bookkeeper that handles all of the log messages. It's an append only, so it's really fast. And its focus too is to manage all of these log messages. And then, so then Pulsar can then focus on doing all of the broker stuff, kind of, lots of things to do too. You are doing PubSub, you have producer producing messages. Broker is responsible for delivery, working with the subscriber, for example. So very highly scalable. And if you want to rebalance, right, let's say, you are in a cluster environment, you need to do horizontal scaling. It works very well too, because if you add, more servers to your infrastructure or nodes or cluster, it actually, Pulsar has the built-in capability of doing rebalancing, because when you do, if you're aware, right, if you work with messaging, you have brokers, you have the topics being partitioned into, managed by different brokers. It can actually do the throughput really well too. So that type of stuff. And then also Pulsar has this lightweight Pulsar function. So if you need, you're building data pipelines and you go through, you can actually have it transform messages too as it goes along. So has that capability and many other features. And also another thing good about Pulsar, right? There are people actually asking me their Java shop doing JMS, right? That's Java messaging. And for Java messaging, JMS, you can only use Java clients. But here in Pulsar, you can actually have, it's multiple language support. You can use .NET as a client too, on the producer side or subscriber side. So that's a really quick kind of go through. And this, again, just a kind of a, kind of pictorial, kind of describing, again, geographic awareness. Also, there's no, well, actually, I should say, this is Astra streaming. So it's kind of supported by data stacks. So, and it's a Pulsar underneath the hood. And essentially, it's Pulsar as a service. So, yeah, it kind of helps you so then you don't have to manage so much things too directly. And then also, just a note too, it's not mentioned here, but we also have Luna streaming if you want to host it yourself, using Helm charts to deploy, that type of stuff too. And then you can buy services, for example. Okay, so now let's get back a bit more into Pulsar. If, anytime, right, you want to do asynchronous messaging, you want to guarantee message order, Pulsar also has that. It guarantees message delivery. Again, very scalable, and it handles spikes very well, and also manage the back pressure too. Uses PubSub pattern, right? Sending, receiving with the help of a serverless broker. Okay, so this is just, again, back to the e-commerce example, is that you can consider using a broker such as like Apache Pulsar to help you. This particular example will just kind of show you, right, how it kind of changes state going through the flow. So using Pulsar to illustrate that. So, yep. Okay, so then we get through to this.
Let me go to the demo. All right.
Okay, thank you. All right, we don't have much time.
Yeah, we're actually not doing too bad.
Yeah.
All right. So, hey, just real quick, there's the link at the top there, and I think this is further on down too in our resources, but that's the GitHub repo that has all of this code and everything in it. And as you'll see in a second, I'm going to demo it out on Gitpod. If you've never used Gitpod, it's essentially a it drops you into like an IDE in the cloud, and you're able to like kind of run everything contained all in one little development environment. It's really, really cool. We use it a lot for our workshops just because it's so easy to help folks config kind of the same environment and kind of have that reproducibility and expect that it's going to work. So that's really great. All right. Let me actually jump over there and hope that they haven't. Oh, they have. Okay. All right, let's reopen my workspace. See, if I was smart, I would have looked at that first before talking on that slide. Yeah, that's okay. All right. And, okay. Let me close through that. Oh, there we go. It's building everything.
Did we share the GitHub link yet? Or?
Oh,
I just thought maybe folks like to follow along. I almost forgot. So
yeah.
Yeah.
You know what? Let me.
Yeah. Too bad there isn't another place where I can write it down.
Oh, I know. Yeah. Like a marker board.
Yeah, like a board. I can write down the GitHub link. Yeah.
Right.
So, yeah. Don't know how
okay. Let's see how we're doing here.
Okay.
Oh, okay. Perfect. It's done. So as you'll see here too, it's rendering the README from our GitHub repo. So we have like, slide decks from each of the week that kind of goes into detail on, like the modeling concerns for every one of the use cases. Oh, yeah, we actually also give out homework for it as well, and folks who do the DataStax developers homework can go ahead and like submit their screenshots and get a badge they can show on LinkedIn.
Yeah.
But anyway, let me go ahead and make sure my environment variables are there. They are not.
There's no way.
Let's try that again. There we go. Excellent. All right, and single sign-ons there. Okay, so now let's do a start. What time are we done here?
I think it's 2:15.
Oh, it's 2:15?
2:15.
Oh,
yeah,
oh, we got
so you
plenty
can-
of time. All right.
Okay.
I was worried there
can
for a
find-
second.
yeah.
Oh, what in the heck happened here?
I'll go find that person to see if I can send the link over there to that TV. Okay. So, just
Oh,
so you know.
yeah.
Yeah. Okay. Sorry. Oh, thank you.
Well, it wouldn't be a live demo if something didn't blow up, huh?
In person.
Oh, okay. Whew. All right, that's something easily fixed. All right. Let's make sure I've got the right database ID out there. And I think, yeah, here we go. Okay. Oh, database ID, sure enough. There we go. We can do a copy on that. And I think it just had the -1 on there. I think that's what threw it off. Yep. All right. Let's try our Maven build again here. Hey. There we go. Okay, so Gitpod, when it senses a that your web port is running, actually you can define the port for it to listen on, but when it senses it, it tries to open it up in a pop-up here. So I'm actually going to allow and then click on this. Oh, hey, outstanding, we have our website. Okay, now if I got single sign-on working okay, I should be able to hit login and hit my Google account. And this should, outstanding. So I can check out my profile. Yeah, sure enough, that's me. Yay. Okay, let's get back to the main here. I really like that Apache Cassandra 3 contributor shirt. All right. Kind of cool here too is that you'll notice as we change sizes, the price updates. I'm an extra large, so I'll go with that. You can add it to our cart.
So folks,
Good. How about I grab a jacket? We have a.
Just
Actually, I think
well,
Mary has
only
it in
one
here.
at a time.
Her data
But
stacks
I cannot
gray
find
track
an AP
jacket.
person. I guess it's okay. I
All
was
right.
thinking,
Again,
oh, the
XL
ideal,
for
I
me.
can write that down.
So we'll add that to the cart. We can go ahead and click the shopping bag icon. Boom. There we go. We've got our items in there. I'll go ahead and place the order. Hey, outstanding. All right. So everything came through here. Now, if this worked and I did everything right, I can go down to my e-commerce streaming dashboard here in Astra and have a look at the topics. Oh, actually, no, it's try me. That's it. Here we go. So if I look at, that would have gone to pending orders, and I just want it to read. I don't want it to consume. So if I connect, I should see, outstanding. There's my order JSON. All right, so now let's say that the process in the warehouse has my order and it realizes that it's going to send this one out to be picked next. So to do that, I'm going to open up another terminal here, and we're going to go to, I'm going to cd to order processor. There we go, and I can do simple maven clean install. I apologize to the Gradle folks if you're in here who've been using Maven. But didn't want to start a dependency management holy war. All right, outstanding. Let me check my target. Okay, so let's do, let's see here. Let's go Java, jar, target, and then ecom, and I want to make sure the Spring Boot one loads. And we're going to say, yeah, I want this order to be picked. So if I say pick, that should go, oh, it didn't like that command. Okay, where are you here? Oh, I got really loud all of a sudden. Okay, so, oh, yeah, pick totally should have worked. What the heck? All right, so what didn't it like? Oh yeah, it couldn't build the couldn't build the URL. Oh, new terminal window.
Oh, that's right. Now you're
Let me resource my environment. There we go. Let's run this again. Hey, there we go. All right, so it found my order. Excellent. And it's got this friendly message down here that says, hey, we found your order, and we've pushed it out to our picked orders topic, which means I should be able to go over here, and if I reconnect to the pending orders, oh, I thought it would say this one was, oh yeah, consumed, okay. And then if I look at, there we go, picked orders, I should see my order sitting on that topic, and there it is. Oh, hey, there's an old one from yesterday. Anyway. All right, so that's the demo in a nutshell of just kind of this thing from end to end, showing all 4 of our use cases, putting it together, showing it in the data store of Cassandra, and then moving things along with Pulsar. Real quick, just to finish here, there are some tips that I'm going to add. Just if you're building like an e-commerce site, these are things to keep in mind. When you're talking about working with money or currency, make sure you're using decimal or big decimal. Decimal is actually a type inside of Cassandra. This website, 0.300004.com, is somebody put this up in jest because it's what happens in Java when you do a print line of 0.1 plus 0.2. It doesn't come out to 0.3. Just a hint up there. So when dealing with currency, always big decimal. That's important. For those of you who looked really, really close at the demo, you'll notice I did not use a TLS certificate. I do not recommend that for running something large-scale e-commerce. I don't recommend self-signed certificates for large-scale e-commerce either. And I will neither confirm nor deny that I've actually seen that happen out in the wild, nor where I worked when I saw that. But moving on. So make sure you sign your site with a certificate and make sure it's from a valid certificate authority. That's a definite point you want to mind there. As well as don't try to write your own tax calculation software. Anyone who's done this, you know that tax codes, especially in this country, change not only by state, but sometimes by county, sometimes by city. Sometimes it's okay to tax shipping, sometimes it's not okay to tax shipping. All of that gets taken into account when you use the proper tax calculation software. Not that anyone builds a site and just does a clean like 5% off the top and that's your tax. I'd save you from that from the outcomes of that. Password hashing. It should go without saying, 2022, don't store passwords in clear text. Although people still do it, unfortunately. Java actually comes with this cool library with the bcrypt password encoder. You can go ahead and take your passwords, run it through the hash, and store the hash. And that way when you compare, you're taking the entered password and hashing it, and then comparing it to the hash you have stored. So compare the hashes, that's what you want. Because if people get that, that's not as big of a deal as getting, an actual password that's out in the clear. So that's another tip I'll pass along on that as well. But hey, otherwise, we've been running some Cassandra days in Europe actually, and they've been really, really successful. We did one in Berlin that was really good, and I think we're doing is it?
Amsterdam? Oh,
Yeah.
Amsterdam.
Yeah. The date's right on there. My bad.
Oh, no.
Amsterdam. Yeah, that's right. That's coming up in a couple of weeks. And then we're going to try the same thing in the U.S. We're going to have Cassandra days. I don't know how many of you are have traveled a bit to get here. I know there's a lot of international folks here, which is super cool. But yeah, I just jumped over here from Minnesota. But if you're in the Bay Area, Seattle or Houston, we're going to have a Cassandra Day on November 10th all at once. And the whole idea is that we're going to give you a ticket to get into a pre-screening of the new Black Panther movie before it actually comes out. So yeah, you'll get to see that along with going to a cool Cassandra Day. And we're lining up some talks from some of the big Cassandra users as well. We haven't solidified anything, so I can't say who. Yeah. But yeah, I'll just leave that. Yep. And then of course we're actually going to get back to doing a Cassandra Summit this year. It'll be our first one since 2018, I think, was the last one that we did. But yeah, this is going to be really cool, and this will be in the Bay Area as well. So that should be a lot of fun.
Yeah. Finally.
Source code repo, Mary, thank you so much for putting that out there.
Yeah.
Real quick, on DataStax Devs is our GitHub repo where we put all of our developer advocacy, source code and material out there. Go ahead, take a look at it. We've got plenty of other projects out there.
That's right. Yeah.
DataStax Developers, is also on YouTube. Our YouTube channel has a lot of great resources too. Not just for Cassandra and Pulsar, but we have some intro to NoSQL material out there as well. If you're just getting your feet wet in the NoSQL world, that's good to check out too.
Yeah. Was going to mention Awesome Astra too. You know what I'll do? I'll share the slide deck here. I don't know how they were gonna. Yeah, right now there isn't a common repository area, but I'll figure it out. Maybe some way of distributing to you. And we also have an Awesome Astra site that you can actually get jump started on, different technologies. It's not just for DataStax stuff, but there are other things you can learn from there. It's called Awesome Astra. So yeah.
Yep.
Okay.
All right. Okay. And then and we have a ton of resources here too.
Yeah, these are specifically if you're interested in Pulsar too, and these are the different links. And also, if you want to sign up for the Astra data, the managed cloud platform, just now when Aaron was illustrating, right, you can use our managed platform, get $25 US dollar credit, right? And every month, it's actually very useful, and it's $300 a year. We don't ask you for your credit card, so it's right in the middle, astra.datastax.com. So sign up for a free account then. And then the rest are links to the different resources. So yeah. Yep.
And I think that's it.
That's it.
I think we managed to plow our way through this one.
Yeah. Thank you so much for coming.